Welcome back to Operating Systems. We are now in Unit 5, Part 1, where we'll be doing more CPU scheduling. So we'll be doing some practice with round robin and shortest remaining time. So just to remember that the short-term scheduler will organize the processes in the queue, them up to be dispatched onto the CPU, and it works very often with all these processes coming into the ready queue time. And brush up on your calculations so that you are familiar with what turnaround time is, waiting time, and response time. And just to remind you, response time is a one-time measure. Wait time is the sum of time spent in the ready state, where response time is that first measurement of wait time, and turnaround time is the total time active. So today we're going to be doing round robin, shortest remaining time. So let's get started. So right here we have 5 processes, and they have staggered arrival times, and we're going to be doing round robin with a time quantum of 5. So let's get started. So our current time is 0. When we get started at time 0, you can notice that none of the processes have arrived yet, so the CPU will be idle for 1 time unit. At time 1, we have the arrival of P1. So now we're just going to give it P1 5 time units on the CPU until time 6, at which time it has completed its CPU burst. It has 5 time units left and a new arrival of time 6. Now the current time is 6, and in our ready queue we have both P1 and P2, and I chose to do this on purpose because on a test or an assignment at this time, either P1 or P2 could go at time 6 because they're both in the ready queue. I'm going to choose to do P2. So I chose to let P2 go to give P2 a chance, and it will go for its 5 time units. It will have 6 left and a new arrival time of time 11. And now we will have to go back and have P1 go because P1 arrived before P3. So we have P1, and now P1 has finished with all of its execution. Now the current time is 16. In the ready queue, we have P2, P3, P4, and P5. So the next one to go, because it's first come, first serve, will be P3. And P3 will have 7 time units and a new arrival time of 21, followed by P2. And again, you just round robin through each of them, giving them each 5 time units on the CPU. So we have P4. And now the current time is 31, so P5 will go. P5 only has a CPU burst of 5, so P5 is done, followed by P3, followed by P2, which will now finish at time 42. And it's important to keep track when you're doing it of the arrival times because it is first come, first serve, so it has to go in that order. So P4 will now go because P4 got there before P3, followed by P3. So now the current time is 47, and all the processes have completed their execution. And after you get your Gantt chart, you can go ahead and do the calculations. So P1 arrived at time 0 and will then therefore have a response time of 0. P2 arrived at time 6 and will have a response time. Oh, I did the total time. Sorry. P1 arrived at time 1 and finished at time 16, so it has a turnaround time of 15 time units. And it has a wait time of 5 time units because it was active in the system for a total of 15 time units, 5 of those time units waiting and 10 of those time units on the CPU. And next we have P2 that arrived at time 6, so its response time is 0. And finished at time 42, but you have to subtract the time 6 when it arrived, so it was active in the system for 36 time units, and it waited a total of 25 time units. So while P2 was active in the system, it was waiting 25 of those time units, and it was on the CPU for 11 of those time units. Next we have P3. P3 arrived at time 8 and first got on the CPU at time 16, so it waited a total of 6 time units for its first response time. And then it finished at time 47, subtract the 8 when it arrived, so it was active in the system for 39 time units. And its wait time, it waited 27 time units. So it was 27 time units it spent waiting and 12 time units it spent on the CPU. P4 arrived at time 12 first got on the CPU at time 26, so its response time is 14. And its turnaround time is 33. It was active in the system for 33 time units, and it spent 25 of those 33 time units waiting. And P5 waited 17 time units before the first time it got on the CPU, finished at time 22, and it waited a total of 17 time units. And then if you take these three calculations, but 5 processes, and divide them by 5. If you add all this up and divide it by 5 for the response time, you will get the average response time, the average wait time, and the average turnaround time. Now we will try another exercise. This is another preemptive algorithm, but this is going to be shortest remaining time, which is shortest job first preemptive. We have 4 processes, and their bursts, you can see by the table, are 8, 4, 2, and 5, and their arrival times are 0, 1, 2, and 3. So we will start at time 0 with P1 because it's the only one that is in the ready queue. But then we have, at time 1, we will have the arrival of P2. So P2, when P2 arrives at time 1, P2 has a burst of 4, and P1 has a burst of 7 left. So that means that P1 will be preempted, and P2 will get the CPU because the shortest remaining time means which one has the shortest burst at that time. And at time 1, P2 has a shorter burst than P1. So now P1 is on the CPU, but at time 2, we will have the arrival of P3. When P3 arrives at time 2, P2 has a CPU burst left of 3, and P3 has a CPU burst left of 2, so the shorter remaining time is going to be P3, so P2 will then be preempted, and P3 will now be on the CPU. So now P3 is on the CPU, and it will continue on the CPU until time 4, in which time it will complete its execution. Now the current time is 4. P1, P2, and P4 are all in the ready queue, so now we will just run them by the shortest job first because nothing is going to be arriving to preempt anything. So that'll be P2, followed by P4, followed by P1. And now they have all completed their execution at time 19, and if my Gantt chart is correct, I can then calculate my response, wait time, and turnaround time. So P1 arrived at time 0, first got on the CPU at time 0, so P1's response time is 0. P2 arrived at time 1, first got there at time 1, response time of 0. P3 also has a response time of 0, and P4 has a response time of 4. P1 has a turnaround time of 19. P2 and a wait time of 11. So that means that P1 spent 19 time units active in the system and 11 of those waiting. P2 has a turnaround time of 6 with a wait time of 2. And P3 has a turnaround time, finished at time 4, arrived at time 2, so it has a turnaround time of 2 and did not wait at all. And P4 has a turnaround time of 9 and waited a total of 4 time units. And you can take these, add them up, and divide by 4 for each calculation, and you will get the averages. So that concludes our exercise on round robin and shortest remaining time. Thank you very much, and we will do some more exercises in the next video.